Hello everyone, welcome back to my channel. This is a video on blue-green deployment based interview questions part 3. So let's start. The first question is, what are the drawbacks of a blue-green deployment? The answer to this is, blue-green deployment offers several advantages, but it also has some limitations. The first point is infrastructure costs. Maintaining two separate environments, one blue and one green, can be costly, as you need duplicate infrastructure for both the versions of the application, which may not be feasible for all the organizations. Second is complex rollbacks. While blue-green deployment simplifies rollbacks, in cases of complex dependencies or database schema changes, reverting to the previous version can still be challenging and time-consuming. The next point is data consistency. Synchronizing data between the two environments can be tricky, especially in real-time applications. If there are changes in the database during deployment, ensuring data consistency across both the environments may require additional steps. The next point is manual management. The process of switching between the blue and the green environments can introduce operational overhead, requiring manual intervention or extra automation to manage the transition smoothly. In conclusion, while blue-green deployments can enhance uptime and minimize risk during updates, they may not be the most efficient or cost-effective solution in all the scenarios. The next question is, how do you deal with the increased price of maintaining two environments in the blue-green deployment? You can answer to this question as, to address the increased cost of maintaining two environments in a blue-green deployment, several strategies can be employed. First is cloud infrastructure scaling. Leverage cloud services that offer on-demand scaling, allowing you to run the green environment only when necessary, for example during the deployments or testing, and scale down when not in use. This minimizes the resources usage and reduces the cost. The next point is automation and resource sharing. Automate the environment provisioning process and use shared resources where possible, such as databases or external services, to reduce duplication and optimize resource allocation. Then comes incremental deployments. Instead of maintaining two full-scale environments at all times, use smaller and more cost-effective environments that replicate only critical components of your infrastructure during the deployment phase. Then comes leverage containers. By using containerization, for example Docker, you can create lightweight, isolated environments for blue and green deployments, reducing the need for full infrastructure duplication and lowering the costs. These approaches allow you to balance the need for high availability and seamless deployment with cost efficiency in a blue-green deployment setup. The third question is blue-green deployment suitable for every type of service or application? Why or why not? You can answer to this question as, blue-green deployment is not suitable for every type of application or service due to certain limitations. First is stateful applications. Blue-green deployment can be challenging for stateful applications that rely on session data or persistent connections. Maintaining data consistency between the blue and the green environments during the switch can become complex and error-prone. The second point is high cost for small applications. For smaller applications or services with minimal traffic, the cost of maintaining two identical environments may not justify the benefits, making other deployment strategies like rolling the updates or canary deployments more efficient. The next point is complex dependencies. Applications with complex interdependencies, especially with third-party services or shared resources, might face issues when switching environments. Ensuring seamless communication across versions can require additional effort. While blue-green deployment offers significant advantages in terms of zero downtime updates and risk mitigation, its suitability depends on the application's architecture, scale, and complexity. For applications with simple, stateless designs or those benefiting from high availability, it's a great fit. The next question is, imagine you are doing a blue-green deployment and traffic switches to green, but users report issues with the new version. How would you handle this situation? You can answer to this question as, if users report issues after switching traffic to the green environment in a blue-green deployment, I would follow the following steps. First is rollback to blue. Immediately switch the traffic back to the blue environment, which is stable and fully functional, ensuring minimal disruption for users. Second point is identify and diagnose. Quickly investigate the root cause of the issue in the green environment by analyzing the logs, monitoring the data and any error reports to identify if it's related to code or configuration or infrastructure. The next point would be fix and validate. Once the issue is identified, fix the problem in the green environment and test thoroughly in a staging environment before redeploying. The last point would be to redeploy green. After validating the fix, gradually redirect traffic back to the green environment using controlled traffic shifts or canary deployments to ensure the issue is resolved. This approach ensures minimal downtime, quick recovery, and effective troubleshooting, maintaining a smooth user experience during the deployment process. The next question is, in a microservices architecture, how can blue-green deployment be implemented effectively? The answer to this question is, in a microservices architecture, blue-green deployment can be implemented effectively by, first point is service level deployment. Deploy each microservice independently in the blue and green environments. This allows for gradual rollout of updates per service without affecting the entire system and minimizing the risk. The next point is API gateway management. Use an API gateway to control the traffic routing between blue and green environments. This enables seamless switching between the versions of the individual microservices and ensures that users are only routed to stable services. The next point is database versioning. For microservices relying on shared databases, implement database versioning strategies, for example, backward compatible migrations, to ensure smooth transitions between environments without data inconsistencies. The next point is automated testing. Perform automated end-to-end testing in the green environment before switching the traffic, ensuring that new versions of the services work seamlessly with others. The last point is traffic splitting. Use tools like canary releases or feature flags for more granular control over which users or traffic segments are routed to the new version, enabling safe incremental updates. By applying blue-green deployment at the service level, ensuring database compatibility, and using advanced traffic management, microservices can be deployed with minimal risk and downtime. The next question is, what would you do if the blue environment is unavailable during a blue-green deployment? You can answer to this question as, if the blue environment is unavailable during a blue-green deployment, I would, first point, fail over to green. If the green environment has passed all the necessary tests and is stable, I would immediately switch the traffic to green, ensuring minimal downtime for users. The next point I would do is investigate blue environment. I would diagnose and resolve the issues with the blue environment, whether it's a network, infrastructure, or deployment problem, ensuring it can be brought back online as quick as possible. The next thing that I would do is revalidate green. Before rerouting traffic back to blue, I would ensure that the green environment is fully validated, stable, and capable of handling the traffic in the long term to avoid regression. The last point would be backup plan. If both the environments are compromised, I would initiate the emergency rollback plan, for example, to a previous stable release or another backup, ensuring continuity while fixing the underlying issues. This approach minimizes downtime, ensures business continuity, and provides a clear path to resolve the issue efficiently. The next question is, how would you handle automation testing and validation during blue-green deployment? You can answer to this question as, during a blue-green deployment, I would handle automation testing and validation as follows. First point is pre-deployment testing. Before switching the traffic, I would run automated tests, for example, unit, integration, and end-to-end in the green environment to ensure the new version meets functional and performance requirements. The next point would be smoke testing. Once traffic is redirected to the green environment, I would execute automated smoke tests to verify basic functionality and ensure no critical issues impact the users. The next point is continuous monitoring. I would set up real-time monitoring and alerting for key metrics, for example, response time and error rates, to quickly detect any issues in the green environment. Then comes post-deployment regression testing. Automated regression tests would be executed to ensure that existing features work as expected and that the green environment is fully compatible with other services. The last point is rollback criteria. If any criteria failures are detected, I would trigger an automated rollback to the blue environment, ensuring minimal downtime and disruption. This ensures that every step of the deployment is tested thoroughly, minimizing the risk of introducing issues into production. Next question is, if you are deploying a new version of an application that requires a new schema, how would you manage this in a blue-green deployment? You can answer to this question as, in a blue-green deployment to manage a new schema with minimal disruption, the following steps could be followed. First point is deploy the new version with the updated schema on the green environment, ensuring it doesn't affect the blue, that is the production environment. Second point is run backward compatible migrations in the green environment, ensuring that both old and new versions can coexist during the transition. Third point is test the new schema in the green environment to ensure everything works as expected with the updated application. Fourth point would be switch traffic to the green environment once the green deployment is validated, making it the new production environment. Last point would be monitor closely after the switch and if necessary roll back by redirecting the traffic back to the blue environment. This approach ensures zero downtime and seamless rollback in case of issues. The next question is, what considerations would you make when scaling a blue-green deployment for high traffic application? The answer to this question is, when scaling a blue-green deployment for a high traffic application, I would consider the following. First point is infrastructure scaling. Ensure both blue and green environments are provisioned with sufficient resources, for example, compute power and load balancing to handle high traffic. Use auto scaling to dynamically adjust the resources based on load. The next point is traffic management. Implement gradual traffic shifting using load balancers or API gateways to avoid overwhelming the green environment. This allows for a controlled transition without disrupting the user experience. The next point would be database scaling. Ensure that database performance and replication can handle the increased load, especially if both the environments are writing to the same database. Use read replicas and database sharding for scalability. Next point is continuous monitoring. Set up real-time monitoring for system health, response times, and error rates across both the environments to detect issues early and prevent performance degradation. Then comes blue-green environment synchronization. Ensure that the environments remain consistent with synchronized deployments, configuration management, and version control to prevent discrepancies under high traffic. Then it is load testing. Conduct load and stress testing in staging environments to simulate high traffic scenarios before pushing changes to production, ensuring the system can handle the scale. These considerations ensure a smooth, scalable blue-green deployment process that can effectively handle high traffic while maintaining the availability and performance. The last question is, how does the blue-green deployment differ from continuous deployment and continuous delivery? The answer to this question is, blue-green deployment, continuous deployment, and continuous delivery are all strategies for deploying code, but they differ in their approach and scope. For blue-green deployment, this strategy involves maintaining two identical environments, blue and green. Only one environment, blue, serves the production traffic, while the other, the green, holds the new version of the application. Traffic is switched to green environment once it is validated, minimizing downtime and ensuring a seamless rollback if needed. For continuous deployment, in continuous deployment, code changes are automatically deployed to production as soon as they pass the automated tests. There is no manual intervention or staging environment, and updates are immediately available to users without explicit approval steps. For continuous delivery, it is similar to continuous deployment but with one key difference. Deployments are automatically pushed to a staging environment but require manual approval to go live in production. It ensures that code is always in a deployable state but adds an extra layer to control before deployment. Let's see the key differences. For blue-green deployment, it focuses on minimizing downtime and risk by using two parallel environments. Continuous deployment automates the entire process, pushing the code directly to production without manual intervention. Continuous delivery ensures that code is always ready for deployment but with manual approval for production releases. Each strategy focuses on different aspects of the deployment process, such as risk management, automation, and control over release timing.